Hi, welcome to my channel. In my last video, I demonstrated how to create a basic Teams bot that answers questions based on the default documents attached to the project and tested it using the Teams test tool. Now let's take it a step further. In this video, we will enhance the bot to answer questions from any document that we choose, making it truly adaptable to your data. Then we'll go through the setup process to run the bot in the Teams client, whether on the web or desktop. Let's get started. Before you begin, make sure you know how to create OpenAI models in Azure and understand the RAG process. If you're unfamiliar with these, check out the links in the description before moving forward. In Visual Studio, create a new project, select Microsoft Teams app, and give a name to the project, My Teams Q&A bot, and create. Select Chat with your data and Azure AI Search as the vector.db search service. Azure AI Search is the enhanced version of Azure Cognitive Search with the semantic search feature. Semantic search is the key in the document-based Q&A conversations. It's not just the word-to-word match, but it goes beyond keyword matching by understanding the meaning and context of queries. For this, it requires vector embeddings, which we can generate using the special type of LLMs, which are known as embedding models. We got the basic boilerplate code created to run this bot that returns answers on the default documents attached. But we don't want that. We want the bot to provide answers on our documents. Let's implement this so that we can upload any documents in Teams and get answers on those documents. When we attach a document and click send in Teams, it uploads it to the user document store and passes the document download info to the bot. We can get the download URL from the download info and download the document to local storage. Then we should create an index in the AI search service, get embeddings, and upload them to the AI search service that adds to the index. Let's implement this now. For this, we need to first create a class, name it as indexer. So this class has three methods: create index async, get data async, and upload document async. Create index async sends a request to Azure AI Search to create a new search index. It defines the schema with the fields for document ID, title, description, and a vector representation of the description. It configures vector search settings using HNSW algorithm. Then the get data async reads the content of the given text file specified by file path. It calls get embeddings async to generate vector embeddings for the text using Azure OpenAI. Constructs a document object containing the file content and vector representation, and it returns the document object for further processing. The upload document async sends the document object retrieved from get data async to Azure AI Search. It uses an HTTP post request to upload the document into the created index or throws an exception if the upload fails. So this process is key for enabling retrieval augmented generation by indexing vectorized text data for efficient semantic search. All right. In the new Teams AI library implementation, the bot needs an action planner object, which in turn needs a prompt manager object. The action planner is used to orchestrate AI-driven actions based on user input. Basically, it converts the user intents into actions or functions to be used in the function calling mechanism of the OpenAI feature. It uses the prompt templates from the prompt manager. The prompt manager uses files to get and define prompts that are compatible with Microsoft's semantic kernel SDK. We need to pass the folder where the folder structure need to be in this format. The folder should contain two files, config.json and skprompt.txt. The config.json defines the prompt configuration settings, and skprompt.txt is the file where we need to define the system prompt. So we need to inject these two classes into the DI container because we need them in the activity handler, which I'm going to show in few seconds. When we send a message in the Teams to the bot automatically processes it like creating plan out of the request, sending it to the LLM and returns the response back in the chat window. But we want to customize this a little bit because we need to upload a document and the bot should answer based upon the uploaded document. For this, we need to add an activity handler. Let me add activity handler class. So this requires several objects from the DI container. So the config options and the indexer, those are already added to the DI container. So prompt manager and action planner, which I just now added to the DI container. Okay, I added the config options also, and let me see whether indexer is there. Okay, yeah, indexer is also added to the. Okay, so what we are doing in this class, so this has a static method, so which we will pass in the bot, which will be called whenever a message is received by the bot. So what it does, first it checks whether the received turn context has any attachments and if the attachment has type file. If yes, then it retrieves the download URL from the response and then downloads the document, then stores the file contents in the local storage and calls the create index and upload document method, which will in turn read the file contents, creates the embeddings, and then uploads them to the AI Search service. And then the planner will send the message to the LLM and gets the response back, which will, and then the bot will return the response back to the chat. And now we need to add the activity handlers, custom message handler to the bot. So there is on activity method in the bot, which we can use to register our custom activity handler whenever a message is received. Okay, that's it. We added all the required code for our requirement. Okay, let me build it. Let me see if there are any errors. The build is complete, no errors. Now before debugging it, let's set up the bot to run in the Teams app. We need to first create a dev tunnel because Microsoft Teams requires a publicly accessible HTTPS endpoint to communicate with the bot. When developing locally, the bot runs on localhost, which is not publicly reachable. So the dev tunnel solves the problem. We can use the Visual Studio's default dev tunnel feature or ngrok to create the tunnel. I will use the Visual Studio's dev tunnel. It should be persistent and it should be public. Okay, the dev tunnel has been successfully created and selected as the currently active tunnel. So let's check. Okay, and let let me uh, change the Microsoft Teams as the default startup project. Next step is we need to set up the bot. In the solution, there is a project named Teams app, which is created by default from the template. We can use it to set up the bot in Teams. Just right click on the project, select Teams Toolkit and click on Prepare Teams App Dependencies. For this, you need to have the administrator account. For development purposes, we can create a subscription using the Microsoft 365 developer program. I gave the link in the description. So log into the Microsoft 365 account with that account and click on continue. So what it does in the background is that this takes care of technical details of setting up the Teams app, making development faster and smoother. It's used to start debugging the Teams app locally in Visual Studio. It automatically registers the Teams app in the Microsoft 365 tenant. It handles the registration and configuration of the bot within the Teams platform. Overall, it configures all the necessary dependencies for the bot app to be run in Microsoft Teams in local. Okay, it is successful. Okay, everything is ready. Now let's run the bot. Okay, first time tasks to add the bot to the Teams app. Just click on add button. And remember, it's only adding the bot to the local Teams app. It's not available to everybody in the Teams, but it's only available in local. Added successfully. Click on open. Okay, our bot is ready. And now let's upload a document. So, and let me ask it to summarize it. So this is CSV file that has logs of an app, which has some info logs and the error logs. There you go, we got the response, and it gave the summary of the logs. Okay, it also gave the error, and let me ask it to provide the stack trace of it. Can you give me the all right? It gave me the stack trace of the error. Okay, let me upload a different file. and ask the same question. First, put in the summary of the document. So this file has C# code. Okay, there you go. It gives the summary. The code snippet from code.txt is an asynchronous method for handling message activities in a bot framework. So this is what I have uploaded, and it gave the summary of the document. All right, so that's how we can build a bot that can answer to the questions on any document that we upload. Hope you liked it, and let me know if you have any questions. You can post your questions in the comments section. I'm happy to answer your questions, and thank you for watching.